What's up, everyone? This is LeetCode 62 unique paths. So we have a robot on an n by n grid, and the robot's located at the top left corner, which is the grid at 0, 0, right? Columns and rows, right? 0th index for both. And the robot tries to move to the bottom right corner, so we're here. We have to move here, and we can only move down or to the right. So we basically have to return the number of possible unique paths that the robot can take to get from here to here, right? Test cases are generated so that the answer will be less than or equal to 2 times 10 to the power of 9. Okay? So I think it's better to explain this problem through an image. So that's what we'll do, right? So this is just example 1, right? So we're here and we have to get here. Right? We have to go from here to here. Now we can only move down or to the right, right? So for example, we can go right, 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 down, down, right. That's one path. Another path could be like this. Right? Another path could be down, sorry, right, down, right, 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 down, right, right, right. So there's a bunch of different paths that we can take, and we have to find out basically how many paths are there, to go from here to here, knowing that we can only go down or to the right, from any given cell. And obviously we have a starting cell, right? So the way we're going to basically approach this problem is, first of all, we need to see if we see some trait, right, with this grid. So at first we start at the first position, right, which is that we can move. There's basically one way to get to the starting position, right? Think of it kind of like a base case. Now, pay attention to the first row, right? To get to here, for example, how many paths can we take? Well, there's only one, right, from here all the way to here, right? Because we can't come from above or anything else. We can only go from the starting position to here. There's only one path, right? Because we can only go right. Um, Likewise, if we're here, if we want to get to here, for example, to this cell, how many paths are there? Well, there's only one path, right? We can go here and here, right? So really, for the first row and the first column, these cells will all be one because there's really only one unique path to get to these particular cells in the grid, right? So think of this kind of like a base case as well, right? Because again, to get to here, there's only one path we can take, which is from here to here to here, right? There's one path. Okay, so now that we've started kind of our base case, kind of set up our base cases, let's examine how we get these how many unique paths are there to get to these particular cells, right? Well, really, if we take the sum of what's above and to the left, we're actually going to get the number of unique paths for that particular cell. But we kind of make it easy on ourselves because we've already solved these base cases. So, now to get this cell, we can just take this and this, the sum of this and this. To get this particular cell here, we just take the sum of this and this, right? So, and just to prove it, right, obviously to get to this cell at the starting position, we can go right and down, that's one path, or we can go down and right. That is two paths, right? Now here, the sum of what's above and to the left, right, would be 3. That makes sense, right? We can go like this, we can go like this, or we can go like this, right? 3 paths. So you're actually starting to see that kind of the trick to this problem, right? So here, right, 1 plus 3 is 4, 1 plus 4 is 5, 1 plus 5 is 6, 1 plus 6 is 7, right? Here, right, we have 1 plus 2, which is 3, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5, 15, 15 plus 6 is 21, 21 plus 7 is 28. Now let me see if there are 28 unique paths for this particular grid. So here, might have to here, and there are 28 paths, right? So you can see we can actually solve this problem doing it like this. This is kind of how we're going to approach this problem, right? So programmatically, how would we do this? Well, really, let's just programmatically, the way we're going to do this is, right, let's just make a grid. So we know in our problem, right, we're given m and n as the inputs, right? So we're just going to use that to create a DP grid, basically. And let's initialize everything with ones, right? Right. I don't want to write it all, but this is all going to be populated with ones. And we know for certain that this here and this here being ones is actually good for us. So we're actually going to overwrite the ones right here, okay? We're going to basically do a for loop and iterate through this and overwrite them and do what we did here, okay? But the reason we just initialize it to 1 because it just helps take care of the problem of populating the 0th row and the 0th column with ones, which is what they should be, right? Because there's only one path to get from to here, for example, or to get to here, right? So we're just basically going to make a grid and populate everything with ones, and then we're going to have a for loop, and we're going to iterate on everything besides the first row and the first column, i.e. the 0th indexes of the rows and the columns, right? We're not going to handle these because they should be ones. Okay, and that's really kind of how we're going to approach this problem, and we're just going to basically use what's above and to the left, and we're going to populate these with some arbitrary values depending on how big the grid is, right? Right? And then at the end of our program, the last cell, right, i.e. the cell that is in the final row and the final column, right? That should be our answer, okay? So the way we're going to do this is, again, we're going to create a DP array, or I should say a grid, right? Think of it like a grid, right? So we're going to do M for this and this. Okay, so everything's going to be set to 1, right? We're basically creating this grid here and we're setting everything to 1. And again, we need to start here, right? And go like this. But we're not going to handle the 0th column or the 0th row. So the way we're going to do that is we're going to say for r in range 1 to m, right? We want to start at 1, we don't want to start at, we don't want to handle any index that is 0 for the row or the column. So we're going to do the range at 1, right? And then for the column, we want to do the same thing. So we're going to see 1 to n, okay? And remember how we found the number of unique paths for any particular cell that we're on? We're going to take the row above and the column to the left, right? So we're going to do r c minus 1, and then we're going to add also r minus 1 and c, okay? And that's literally, that's it. That's the problem, right? Remember, we need to get the value at the last index for the row and the column. So because we're using Python, we can just do -1, right? Which basically gets the last value. And so we do dp -1, and should work. What did I do? Little syntax error here somewhere. Oh, I think it's right here. Whoops. Sorry about that. Should be good now. So yeah, we pass all our test cases, and boom, there you go. So yeah, we're basically just reusing the values from the, when we're at a particular cell, we're using the values above and to the left to find the, to calculate the number of unique paths for that particular cell. And the reason we can do that is, of course, because we did kind of the setup by setting everything to ones in the 0th row and the 0th columns, because again, those are kind of like our base cases, because there's only one unique path to any of these cells here. There's only one unique path to any of these cells here. Why? Because we can only move down or to the right, right? So we're not going to, so for this cell, we're never going to come from anywhere else other than from the left. There's only one unique path, right? Whereas if we're down here, right, we can come from this path, we can come from this path, we can come from this path. So it's more complicated for the other cells, but the 0th row and the 0th column, we should be good. Anyways, I hope this helped, and I will see you in the next one. Peace out.